My name is Igor. Thanks for coming. I work for XING as a software architect, and this talk is going to be about our journey to containers and Kubernetes and all the stuff around it. So let's begin with the question: why containers? Like, why should we go to containers at all as a big organization, right? And XING, if you don't know about it, it's a career website basically with some 16 million active users. We are mostly present in the German-speaking countries, and we have like 1,500 employees. So like back 2 years, we had 2 data centers. We mostly used VMware and Chef to provision like hosts and then run our stuff on those hosts. And we had Ruby, Scala, Elixir, Perl, and some other languages, and mostly like centered around that GitHub, Jenkins, and Capistrano deployments. And of course, there were some problems right with that, and those were kind of typical when you have one central ops department, because you want to have some resources. You create an ops ticket, that ticket gets worked on, so basically you have slow resource provisioning. Sometimes you have mistakes in host configuration, and that basically results in like complex boilerplates for your applications. And another thing was that we were still kind of sticking with the startup-like practices in terms of like many developers got access to many things, right? And we wanted to improve that. So what do you do like in 2017 if you have those? Well, you jump on the container hype train, right? Like containers, yay. So how do we do that? Well, I'm going to draw like the big picture now and gradually expand it. So the big picture looks like this. You have your code, then you somehow get the containers out of that, and then you run them somehow, right? So let's zoom in. How do we build containers? Of course, like Docker was the thing, and it's still probably, well, the thing nowadays. And what we found out, what we were afraid of, and were kind of relieved that Dockerizing is easy. Actually, it's not a big deal. But Docker files as a means to like, organize stuff, they are not cutting it, because imagine you having like 100 Docker files with all the dependencies and things. If you want to do like operating system updates or install some security patches, that's not working right. So for us, Docker file turned out to be a complex boilerplate that we wanted to avoid. So we wrote our own Docker building software, right? It's called Docker Build. It basically brings the base images, centralized configuration that we wanted, and you can do some, production or development targets with those. And that's what the configuration looks like. So you select the type of your application, like a Rails application, right? You select the framework version with the configuration. This is your, can you see that? Yeah. So that's your image name, basically. You can switch operating system releases if you want, and those are curated by the central team. You specify your build packages and runtime packages and some custom commands to, say, compile assets or something like that. And the Docker build comes with Docker test, because you want to test your images when you build them, right? Docker test is basically a wrapper around Docker Compose. It pulls the dependencies, it cleans everything up after the test is finished, and the configuration is, again, another YAML file where you specify your dependencies, like MySQL and Memcache in this case. You specify your main image that you want to test, your entry point with your test suite, and links to your dependencies in some configuration. So with those two tools, we can expand our big picture to having GitHub. Then we have those tools to build the containers. Then somehow we run them, and yay, our website. So how do we actually go from this? We somehow run them and do something to them. So first, of course, we have to have some image registry. And this is kind of an outtake, right? We tried the Docker Trusted Registry, and we're not super happy about it because, well, there is, for example, no garbage collection, and there is no like UI, and we were not happy with the off-the-shelf UIs that were there. So then we switched to Key before it became open source. So we used Key Enterprise, and it works, like nothing to complain about. So the big picture looks like this: you have your code, you build the images, you push them to the registry, and you somehow run the thing. There's a pause sign. That's for me at the like bottom level. So runtime. Let's look at the runtime. How do you run containers? Well, in 2017, we already had some experience with running containers. Some departments of the company. We used Marathon and Mesos. And basically, when we said, okay, now let's focus on like deploying that on scale for the whole company, we quickly realized that Mesos doesn't really cutting it, because, well, there are some problems with, say, running one-shot tasks, right? You had to install some third-party components to do that. There is no basically guarantees on CPU and memory if you wanted that, and you wanted that for some applications. Granular access control doesn't exist. So basically, and you think if you think of that as a developer product, like the amount of documentation you had to write for that, that was just horrible. So we took a step back, and if you take a step back, you realize that containers in general is a huge change. It's like it touches everything you do in terms of like running your software, right? And there are many parties interested in that, in different things actually. So some people inside the company want to automate everything, of course. Some people care about the resources and they say, let's utilize everything that we have. Of course, there is a security team, and basically the question boils down to this one: what orchestrator do we use? And we found ourselves, in a deadlock situation because, security says, okay, that thing is more secure, but we say, but we want more resource utilization. So how do we resolve that? We took another step back, and the answer to what orchestrator is, surprisingly, a value system. So we needed to come up with the values, like what we value above what else. So this is our actual XING platform values, like the values for our internal platform product. And the first one is engineers' productivity. We value that over everything else. Next comes security, and it comes second, and it doesn't mean it goes out of the window, right? It basically means it's prioritized a bit less than productivity of the engineers. Maintenance cost was not really like super high in priority, and platform resilience and hardware utilization, those were pretty good already. And of course, for the new platform, we wanted to keep the results pretty much as good as the old ones. So that's why they were like prioritized as last. So after looking at that thing, after having that list, basically it turns out that Mesos and Marathon were like out of the list completely, and the final battle was between the COS and Kubernetes. They were really close to each other in 2017, and we decided to go with Kubernetes because, the feature set is pretty much complete. The documentation is awesome. It's open source, and we went to a few Kubernetes conferences and realized that there are so many companies backing this up. So yeah, that's our choice. So the updated big picture looks like that. You get your code, you build the containers, you push them to the registry, then you somehow make the deployments happen in the cluster, right? And then that's your website. So how do you make this deployment thing happen? Let's talk about the deployment pipeline. And again, solving this problem, right, requires looking at the platform values, right? On the first place, we have engineers' productivity. So what do engineers do in general? They write code, right? They work with the code. So we start with the code. The code lives in GitHub. What do we have in GitHub? We have organizations. We can create Jenkins folders based on the organizations, right? We have branches. We can create pipelines on that. And we have events to trigger those pipelines. So we took Jenkins, which we had already. We installed folders plugin, the Kubernetes CLI plugin, and our Docker build and Docker test tools. And it got us there. So basically you have Jenkins, some stuff installed there, so you can build your images, and then you somehow push them to key, and you make the deployments happen. So how do you actually make the deployments happen? Of course, Kubernetes comes with that thing, kubectl, and we quickly realized it's not cutting it again. Because you have to duplicate the Kubernetes manifests if you want to reuse parts of them, right? For example, and it's pretty common, you have your pod to run the application, and you also have pretty much the same pod to run the migrations for the application, right? So there is duplication. You have to do something about that. There is no resource creation order. That was really big because many applications come with the configuration, right? You have to have configuration as a config map. And kubectl, if you try to create like all the manifests, there is no order. So your application could be starting before the config map is created. So it's going to be failing. And the status of kubectl, that kubectl reports, is basically the success of pushing the manifest to the cluster, not the success of the deployment that happened as a result of that. So we chose another tool. It's called Kubernetes Deploy. It's made by Shopify. It's open source. It supported templates, and we contributed partials. It also allows some nice stuff like secret encryption and proper status reports. And of course, it has deployment stages, so the configuration is deployed before the actually the deployment happens. And with that tool, we can have finally a proper Jenkins pipeline, right? And this is the logic behind. You check out the code, you build it, you test it, you push it to the registry, and then you Kubernetes deploy the thing. So what we did with the Jenkins pipeline, we implemented it as a Jenkins library in Groovy. It took us quite some time, and it was rather painful, but I think the result for the developers looks really great, because that's basically the Jenkins file, like the whole pipeline, right? You include our library. You say, this is my Docker image name, which will be like pushed to and then fetched from the cluster. This is my namespace in the cluster, and hey, pipeline, do your work. And that works. But yeah, it's really hard to debug. So if you want my advice on using Jenkins for that, like not the new tools, but the older Jenkins, it really gets the job done, but be prepared for the pain. And there will be a lot of pain. So with that, the big picture looks like this, right? We have, on Jenkins now we have our basically building the images. We also have Kubernetes deploy that pushes the manifest, and we have the container registry set aside, where the cluster pulls the images from. So if you look closely at that image, there are some areas where you have questions, right? Like, for example, that code path. Who creates the folders, right, on Jenkins? Something or someone should create them, and that's not super cool. Who actually sets the permissions on the clusters, right? Because we wanted to improve security, so you cannot have like everyone can access to everything. So someone should set the permissions. Also, who sets the permissions to pull the images from the cluster? And all that is basically configuration, right? You have your systems and you have to configure them. And if there's one thing I can tell about the configuration is that it goes hand in hand with automation, right? We had to automate that stuff. And on Kubernetes, there's a really powerful pattern which actually Kubernetes itself utilizes, and you can also use it. It's called Kubernetes controllers or custom controllers. And the controllers are really simple as an idea. Basically, you have some system. You observe the state of the system, and you change it to be the desired state, like your desired state of that system. And then you repeat. It's a control loop. So looking back at platform values, again, we have engineers' productivity at the first place. So what do? We start with the code. On GitHub, we have organizations. So we can, based on organizations, a custom controller can create Kubernetes namespaces and Jenkins folders, right? So no one has to configure that. It happens automatically as soon as something is changed on GitHub. Team membership, we can map that to deployment permissions. And branches and events, well, pretty much the same, right? Pipelines and stages and pipeline triggers. So let's rearrange the big picture a little bit so we have some space. The first thing to add is one custom controller which takes organizations from GitHub and creates folders and credentials on Jenkins. Another custom controller fetches the organizations and teams from GitHub and creates namespaces and RBAC roles and authentication keys and whatnot in the cluster. And another custom controller fetches repositories from key and creates secrets on Kubernetes. So from your namespace, you can fetch the images from the specific repository in key. So that's kind of cool. That basically means you can push to your repo on GitHub and get the software running on the cluster. But you can pretty much guess that HTTP arrow, the long one on the right bottom, it's pretty silly, right? That's not the reality. That's not how it happens. So let's talk about integration. How you integrate this whole thing with the outer world. Well, the reality is that, of course, you have to have some kind of load balancer. And since we have 2 data centers for redundancy reasons, we have actually several Kubernetes clusters. So again, speaking of developers and their productivity, what if they want to do some change on the load balancer, right? Like expose a new host name or change some root? Well, I guess you know the answer, right? You don't want to do that manually. You want a custom controller that does that. So there is another one which fetches services and ingresses from the cluster and creates rules on load balancers. Another thing is, since our applications are kind of tightly coupled to each other, or they have some common things like message bus, right? We have some shared configuration between the applications, and we store that configuration in console, which basically the configuration translates to environment variable. So how do you get that into the cluster, right? How do you do that? I guess you know the answer, another custom controller. So we have a custom controller that reads values from console, listens to the changes, and then it provides config maps in the cluster, which, well, the applications read natively in the cluster. So if you reflect a little bit on that picture, you see that custom controllers are everywhere, and they do so many different things. And looking back at the principle, custom controllers, if you look at this loose definition I gave, right, is something that just observes the system, changes the state to the desired one, and basically repeats this loop. It's something simple, right, like a small keychain knife. But in fact, what you can do with that is so much more. You can do so many things with custom controllers. I mean, really, almost everything, right? It's a very versatile principle. And we use custom controllers for many, many things. Like, for example, Kubernetes does not support or does not allow automatically reloading the application when the configuration is changed, right? What do? A custom controller that observes the config map and redeploys the application. Graceful node restarts. Sometimes you have to restart your cluster nodes. Well, we wrote another custom controller that observes the labels on the node. So basically, you go label the node, and the custom controller kicks in and cordons it, drains it, restarts, and brings it back. Docker runtime fixes. If you attended the talk by my colleague with all the Docker problems and stuff, he already talked that we implemented some custom controllers that observes the internals of the Docker and kills the necessary processes if something goes wrong. Metric collection setup is also another thing. So basically, you can say, okay, if I label my application a specific way, there will be a custom controller kicking in and configuring metric collection for that application, because that means the application implements a certain endpoint. Or cross-cluster service discovery. It's also a custom controller that, again, configures a load balancer in a specific way to allow cross-cluster communication for one application that is distributed. So if you look at this picture again, looks like all the technical stuff is figured out. But if you're a developer, like not the one who invented this monstrosity, if you're a developer in the company and someone says, okay, deploy your code on that, you're like, whoa, like where do I even start? There's so many moving things, like how do I begin? So how do we support developers, right, in the company? Because our team who created this, this whole system is less than 10 people, and there are some 400 or 500 developers in the company, and the plan was to move everybody to the new platform. So the first answer, of course, is documentation is king. We write a lot of docs. I mean, it's inevitable. Even though the documentation on the tools is great, like Kubernetes is really well documented, and we try to choose tools which are really documented themselves, we still have to write a lot. So we have a separate documentation website. It's something about 30,000 words. And if you wonder about that confused man in the skull, it's 30,000 words is around Hamlet, the size of Shakespeare's Hamlet. So, and still probably not enough to really realize how big is the documentation. So this is a recording of me. I expanded all the table of contents and just scrolling down. That's how much stuff we have. Yeah, and Olympus is the name of our internal name of our product. So one thing about the documentation that you might take away is that we found a specific way to structure it properly, right? Because this amount of docs, it needs a proper structure. And the structure is pretty simple. Basically, first thing you do, document components. And components is what they are and what they do, not what you, as a developer, can do with them. You separate those things, just what they are. The second part is tasks. Those are basically daily routines, right? You document those, like how do I restart my application? How do I encrypt secrets, right? And it should not take more than 15 minutes. And the other part is tutorials, which are long stuff like migrations, tuning guides, and things of that nature. So going back to the big picture, we have to put the documentation there because, well, it's a lot. And it's still not enough. Because there are cases that people miss onboarding, for example, or there is some production problem. And since there is basically a platform which is super big and runs everything, you want some person who's aware what's happening inside to support you. So we ended up with a support channel. And with the support channel, we have a role which we call Argonaut of the Week, because the system is called Olympus. And that's a role for 1 week, and we rotate within that role. Basically, for that person within the week, the support channel is the only duty, right? That's the #1 priority, and it helps a lot, because we have basically this channel is the safety net for completing the onboarding within the company, right? Well, the company is big. You cannot have everything working perfectly, and we are the safety net for the company, basically for onboarding the the last step. We also help resolving incidents, and of course, we get feature requests as a team who supports this platform. So going back to the big picture, we add the support person. One other thing, I think we haven't seen the platform values for a while. Let's look at it again. Engineers' productivity, right? Still in the first place. So what would engineer like to do with the whole system? Well, I guess the engineers like to mess with things, in general. So, and to mess with things, you have to have some permissions. You have to be able, say, to run the build commands locally, right? Or to run the deployment thing, just the deployment part of the pipeline locally. Or you have to have access to clusters. And how do you do that? Well, we ended up with writing our own command line interface. And our command line interface is a single binary. It has all the dependencies like a proper version of kubectl and Kubernetes deploy bundled within it, and that's really important because it has automatic updates. So when we update the clusters, there is no problem like, oh, my kubectl version is not compatible, what do I do? Like brew, update, whatever. No, nothing like that, because our CLI comes with the dependencies. And it does some cool stuff. One major was something we called Olympify, basically because the platform is called Olympus. This is the script or the CLI command that generates all the, well, basically templates tailored to your application. Like it detects your application type, it writes the image build config, it writes the config for the Jenkins pipeline, and all the Kubernetes manifests you might need. And that helped a lot during the migration. And we have a bunch of day-to-day commands, like restarting and deploying the applications from the command line, encrypting secrets, and things of that nature, running one-task jobs, authenticating in the clusters. So some advice on rolling your own CLI. Bundled dependencies are really awesome. I mean, that really helps because you have to update some components, and still, since the whole thing is moving so fast, some versions are not really compatible with the others. So having bundled dependencies is really nice. Built-in help is a must, and don't try doing that with Bash. That's my personal one, because we began with Bash, and you quickly realize it's not really a programming language. It's hard to write tests. It's hard to debug. So yeah, use something else. We used Go. So going back to the big picture, well, we add the CLI tool, right? That black box. And maybe one thing else, like I can talk about a little bit, is that I imagine you want to monitor this thing, right? And monitoring and observability is a whole topic in its own. But I can briefly tell you that we found the Prometheus format, not the Prometheus itself, but the format very useful, because it employs basically this principle of pull model, right? So for the application that wants to expose some metrics, you just expose the metrics endpoint, and you don't care how the metrics are collected. So it's really easy to add. And actually, many tools in this container area, they already have Prometheus endpoints. There are tools that allow you switching the model from pull to push. So you can use something like Telegraph to actually get your data into, say, InfluxDB and Grafana, as we did, because we had that before. And currently, we're looking into Thanos, which is something on top of Prometheus to make it work on our scale. So this is the kind of final big picture. And I mean, look at that. That's so many things, right? And not all of them are just pure technical. So let's reflect on the results and observations. Basically, now we have almost like more than 200 applications. This Kubernetes thing we call Olympus is the platform. All production applications that we could have migrated, we are migrated. So if you open XING now, it runs on Kubernetes, on this monstrosity that I showed. It's basically 9 clusters, 100 namespaces, and 7,000 of pods. And I know my colleague told you a different figure. He included the development environment, which is a different story. It's like thousands more pods. So, and another cool thing that we observed is what I call proliferation of miscellaneous apps. Basically, people started deploying their kind of dashboards, their Hack Week experiments. Internal IT started deploying their like room booking panel software on the cluster. And to us, it's a signal that this stuff is good. I mean, it works. People like it. I guess another takeaway is know your values. It helps a lot when you design a system that big that touches so many people's daily lives. You have to know your values. And maybe to sum it up, like super short, when you want to put your organization on Docker or containers, right? This is the picture you might have in mind. Like you take Docker, you slap Kubernetes on top, and you're golden. But in reality, you have to have so much more. Thank you. I'm not sure if we have time for questions. Probably not. Oh, no, we do. So we do. Anybody? Questions?
Share slides? We share slides?
I will on the tech XING. Like, I will try to do that today.
Yeah. How long did it take to build it?
We started at 2017, and we started the migration last year. So like a year and a half. From 6 to 8, 9. So the team was like varying in size.
I would be interested in your motivation here. Sorry.
Oh yeah, sorry.
I would be interested in your motivation for Thanos. Is it long-term storage, or what did you had for use cases for Prometheus storage?
Yeah, basically the thing about Thanos is if you take like out of the box Prometheus, right? We have too much stuff to store in it, so it doesn't work really, it doesn't perform well. So the option is, if you still want to keep Prometheus, is to go to this hierarchical, like, bunch of Prometheuses doing the retention on their own and aggregation, and we didn't like that because that looked like, a pain in the back to configure and maintain. And Thanos basically gives us really long-term storage. It gives aggregation out of the box. So convenience, I would say. Convenience and actually the ability to handle the amount of data we have.
We have seen that in the presentation. It's more or less developer-friendly platform.
Yeah.
What about the operations of this kind of platform? How much it takes to upgrade underlying infrastructure?
Okay, so the question is, like, the platform is focused around developers' convenience and what it takes for operations to actually handle that. I think operations are also pretty happy because many things are standardized, like, for example, new node installation, right? The cluster is resilient enough so you can take out the node and you can do something to it, you can put it back, it doesn't work, you take it out, and not many things happen. So I guess, yeah, I mean, I don't think it's problematic for ops either.
How do you update your control plane? Is it easy too?
Well, it depends. Usually, so we have multiple clusters, right? We have 2 production clusters and 2 preview clusters, and we also have like miscellaneous preview clusters. So what we usually do is we take some cluster that is not super important, we try updating it and seeing how it goes, right? Most of the time it goes well. If it doesn't, then we start the investigation. And the team who works on the platform, it combines both operations people and, well, backend architects people. So usually we find the problem pretty quickly. And then we decide what we do with that. Like, do we upgrade the operating system, or maybe we roll back the Docker version, or stuff of that nature. But in general, updates are not super painful. Sometimes it just takes time to find out what the issue is about. And the issue is usually not caused by us, but by the software update, actually, itself.
Does this platform run on its own cluster or on the same cluster as the production?
Same cluster. So we deploy controllers on the cluster itself. Yeah. All right, I guess that's it. Thank you very much.